So this is going to be a video on how to understand algebra. This isn't going to be how to do specific algebra. This is just how to understand basic concepts to better help you handle problems as well as handling future problems. So this is just a very basic introduction. And this is typically stuff you're not taught in the classroom for the sake of time and efficiency. So this is going to be a little bit more than just numbers on a paper to you. The overall goal of this is to visualize what the equation and what the problem is telling you. If you can't visualize it, we're going to get it to where you can by untying the knot. And you're going to get what I mean by that in just a quick second here. So this is SlopeIntercept Form right here. This is where you want to be. This is easily readable. Here we can see that slope here. This is the slope M is highlighted in the purple area here, and then the additional movements here are highlighted in blue. So the B here is the y-intercept. So this is just moving along where we're going to encounter the 0 point here on the y-axis. So an example of this is y equals 2x plus 1. And we have that right here. The plus 1, really just click that into place, 1 up above the 0 line here, 2 up for every 1 right. This is just the slope here. We'll get to that in a second, but that's just what the positive 2 integer means. We're going to go up 2 and then to the right 1. Next up, we have the point slope formula, using a slope and 1 point to get a line. This is very similar to what we just saw with the SlopeIntercept form. It's just plugging the stuff in. So here is the formula right here. The y here is going to be the placeholder y. See how there's no number next to it? We don't deal with that just yet. So we're dealing with the first interval of y here, as well as the slope right here. We plug the slope into m, as well as the x-intercept right here. So this is the incomplete form. You're probably going to get an equation very much like this as a practice problem. And here's what I mean by untie it. We need to just plug it in and start with PEMDAS. So let's start with an example here. Y minus 3 equals 4, and then in parentheses, x plus 2. So let's start with the parentheses. That's the first thing in PEMDAS here. Let's highlight that in yellow. Distribute the 4. So that's going to give us 4x plus 8. We're not going to mess with that side just yet. And then we move on to the next step, which is adding 3 to both sides to cancel. This is a mixture of the addition and subtraction PEMDAS. So just going to add 3 to both sides, canceling that 3, and then adding 3 to the 8 to give us the 11. So that'll give us y equals 4x plus 11. Now this is graphable. This is the SlopeIntercept form right here. So we've completed PEMDAS. We didn't touch the exponent, multiplication, or division. So let's go over to the graph. Begin at 11. So we're going to go all the way up here to 11 and put that first dot. That's where it's going to cross the y-intercept right there. We go down by 4 and then left 1. We could go the other way, but the graph kind of ran out. So a side note here, just to understand what I mean by all this, is if the x is positive, which this one is, we can either go up right or down left. Essentially, you want it pointing upwards. You're going to want it pointing upwards on the right-hand side here. But if it is negative, you're going to want it pointing up in the opposite direction, up left and down right, so a downward slope. So because this is a positive x value, we're going to go ahead and draw the line down 4 and left 1. And you can keep going if you want to get a good steady line. Down another 4 and then left 1. We'll end up at -2, +3 there. Anyway, let's continue. So we have slope formula here. Now we have the ability to graph a line. Great. So how are we going to get the slope if all we have are 2 points? This is where you can get that. This is basically just the difference between the 2 points. We're comparing and contrasting, basically. So an example of this is, let's find the slope of 2, -2, and 4, -1. You can see I've highlighted these to match these, just to make things a little easier. We categorize these. We have, let's start with the y's here. So y2 minus y1, we plug that in here. x2 minus x1, plug that in there. -1 minus -2. An easy way to do this is to imagine that this right here is a plus sign, so -1 plus 2 is +1, while 4 minus 2 is 2. So the slope of this graph is 1/2, or 1 up for every 2 right. And you can see here that checks out, 1 up for every 2 right. So let's move on. We covered how to get the slope formula from 2 points. We can also graph it based on the point slope formula over here with just the slope in 1 point. So let's move on to midpoint. Now this isn't as important, but this is just good to know, just as a concept. So midpoint is basically the sum of the whole of either x or y respectively, and then cut it down the middle in, half, hence midpoint. This is a little bit different because we're using the plus sign here. And before we were just taking the difference to get the slope. This, again, isn't that important to know, but just the concept is. Lastly, we have distance, and this is where we get into good old Pythagorean's theorem. This is probably going to look a little scary. There's way worse trigonometry, believe me, so this is refreshing for me. So we have this big scary looking thing here. So this is essentially what we had with the slope formula. So let's start. We're looking for d here as distance. Basically, this is saying if we have this value, the difference of the two x's here, as well as the difference of the y value here, if we have these two values from these 2 points here, we can find everything in between from the farthest point, hence d. This is just covering like what's on the line. And this gives us an exact value. This is basically converting this equation into an actual number. It no longer has its variables and such. In the next video I'm going to do of this, I'm going to talk about imaginary numbers, as well as getting a little bit more in depth into radicals. Thank you very much for joining me.